Okay, hey, good afternoon, everyone. My name is Jeffrey Gillan, and you have tuned into NextGen Geospatial, which is a U of A data science workshop. We're coming to you from the Weaver Science and Technology or Science and Engineering Library on the campus of the University of Arizona. And so today we're going to continue. We didn't have anything last week because of spring break, but we're going to have a new session today. We're going to talk about something called SpatioTemporal Asset Catalogs. So let me start sharing my screen. And we'll get rolling. Okay, so here we are on the course website. This is the GitHub website. This is where all our course material is. Here's the homepage, NextGen Geospatial. Here, let me just post this into the chat here, in case you'd like to access the content yourself. That would be great. Okay, I just posted it. All right, let's scroll down to calendar. All right, so we find ourselves at this date, March 12th, 2024. I'm going to talk about SpatioTemporal Asset Catalogs. So the last 4 or 5 sessions have been all about talking about cloud native geospatial. And so we're going to do something a little different, and though it's in the same, I don't know, arena, sort of speak. We're not going to look at a specific format, a cloud native or cloud optimized format. This time we're going to talk about catalogs, things that can help us discover and catalog and organize and share geospatial assets. So let me go into the content here. So SpatioTemporal Asset Catalogs, what are they? Well, let's give some quick definitions here. So a SpatioTemporal Asset Catalog, or STAC for short, they are JSON and or geojson files. We'll talk about what that means in a little bit. All right, so they're just JSON and geojson files that describe and catalog geospatial assets. And the idea is that everyone around the world that's producing geospatial data in some regard if everyone followed the same protocol and the same standard, then we have a general way or an identical way to share and discover and get geospatial data. So these JSON and GeoJSON files are essentially metadata. They are not data themselves. They are data that just describes geospatial assets. And they've been produced in kind of a standardized way. And if we all do it the same way, then we are making essentially one giant geospatial catalog, that could go across the whole world. So that the assets themselves can be any geospatial data. It could be all the cloud native ones that we already talked about, the cloud optimized point clouds, the cloud optimized geotiffs. It could be data cubes of some kind, the ZAR files that we talked about. It could just be, the old fashioned geospatial data like a shapefile or a geotiff. It could be anything, any geospatial data. But we can use the STAC protocol, the JSON and GeoJSON files, to describe it as metadata in a standard way. So STAC has been kind of this open collaborative effort across the geospatial community. Whole lot of different groups are using it. So it's kind of a rally around trying to do things in a consistent way. So we're not always reproducing the same work. We're not reproducing how metadata is created. We're not reproducing how APIs work. Let's just do it all the same way. So that's kind of the goal. So there's groups like NASA, European Space Agency, US Geological Survey, Google Earth Engine, Open Topography, Maxar, which is a satellite imagery company, Planet, which is a satellite imagery company, and Microsoft Planetary Computer, just to name a few, are all buying into the STAC catalog type of metadata standard. And so it's that's the important thing about standards, is that everyone, it builds momentum and that everyone tends to glom onto one. Otherwise, we're just building ever more standards, right? And hoping everyone does one. So it's really nice that there's momentum, and then there's a community of people all saying, hey, let's all do it like this. And so I think I think it's a nice format, it's a nice standard, and so I myself am also glomming onto it and telling other people about it in hopes that it becomes a stronger standard. Hey, we got a question from Ravindra. Go ahead.
Hi, Jeff. Can you please tell us like a little more about, can you please define JSON and geojson?
Yep, I was just about to get there. Just about to
Okay,
get
thank you.
there. So I was just kind of giving the big picture first, then we'll get into some of the details. Okay, so we're using the STAC model here. Let's say geospatial assets, they can be anywhere in the world. It's best if they're stored somewhere in cloud storage, but that could be anywhere. That could be on Cyberse, that could be in Amazon, Cloud Bucket, it could be on Google's cloud or Microsoft's or your own server or something. It doesn't matter where it is in the world. If we all use the same STAC standard, metadata standard to describe our geospatial data, then we're making one giant catalog, so to speak. But we still have to have like a centralized place. If I want to go look for all of these STAC catalogs, how do I find them? Okay, we still need to have like a centralized website or two. And so the places that they are doing that is the STAC browser and the STAC index. So those are a couple websites, and we'll show both of them to you, of like the hub of where you can go to then go find where all these STAC catalogs are. So here's my little graphic, my little cartoon showing what this is supposed to mean. I mean, there's geospatial data somewhere in the cloud, but it's all being described the same way using the STAC protocol. And then using STAC index or STAC browser, those are websites. You can go to those and then find, all of these catalogs. And the idea is that we can search through the catalogs either through our web browser or programmatically through Python, and do it all in a standard, the same way. And so it really simplifies how to find, discover, share, download, stream geospatial data from lots of different people that are providing it. Okay, so that's the big picture of what STAC catalog is. Now, how does this catalog structure work? So the catalog structure is a nested and hierarchical files of JSONs and GeoJSONs. Now, these are very lightweight files. I'll show a few examples here in a minute, but these are just, you read through them, they're just kind of like text files that look like metadata. But we organize them in this tree, this hierarchy. And so the ones to know about are catalogs, collections, items, and assets. So a catalog is just kind of think of it like a directory or a folder. It's the root folder, the base folder. Everything else is within that. And so that's the best way to describe a catalog. It's just like the whole container for everything. And if we drill down, we can go to collection. Now, collection could also just be a directory or a folder, but it can include some other interesting things, like the bounding box or the extent of the geospatial data that is within the collection. It can have the license type, is this open source? Is this proprietary? It can have keywords. It can just provide you more rich information about potentially what you're about to get into. And then we go to an item. So an item is kind of like the core atomic unit, which generally represents one spatial temporal thing or one spatial temporal item. So as an analogy, you could say like one Landsat scene, satellite imagery scene, that could be an item. All right, so catalogs and collections are JSON formats. The items themselves are GeoJSON. A GeoJSON is just a JSON, but it has coordinates in it. About the same thing. And then finally, we get to the assets. The assets are the actual files that we are interested in getting. They could be geotiffs or cloud optimized geotiffs or point clouds or ZAR or anything really, shape files or whatever. So that's the actual things that we want to download or stream and work with. The other things, the catalogs, collections, and items, are simply metadata describing the geospatial assets, and they do so in a hierarchical nested way, so it's all organized, and you can. Well, we're going to show you how this works in a very visual way here in a second. So catalogs, collections, items, assets. Let's look at an example of what a catalog looks like. Ravindra.
So Jeff, so all these catalogs, collections, and items are related to a particular asset.
It can be done in lots of different ways. Let me go through these JSON and GeoJSON files and see if you still have that same question.
Okay, thank you.
Okay, so here's an example of a catalog. This is a JSON file format, all right? And so this is all it is. It's these are the standard things that have to be in it. And so part of the STAC protocol, the STAC standard, is like it has to include these first things. And then everything else in here is just links to like the children, the collections and the items. So this is all of what a JSON is this. This is what a catalog is. Right. Let's get back out. All right, and then what's a collection look like? It's also just a JSON. It looks similar. So the only difference is it has a bit more information. You can have a nice description about what is going to be in there. Let's see. It often includes a bounding box, which is like of all of the items within this collection, here is the bounding box that they all fit within. There you could list the temporal aspect, like within this catalog or collection, here is the time range we're talking about. Here's the license, who's allowed to use this data and for what purpose. Then you can include other kind of characteristics or properties of your items or assets, like what kind of platform, what satellite was this, what kind of instruments, what's the ground sampling distance or the pixel size, cloud cover, kind of go on and on. So that's what a collection is. All right. And an item, here's an example of an item. This is a GeoJSON. So at first look, it's going to look quite similar, only it has geometry involved in it. And so that's what makes a GeoJSON different than a JSON. It actually has coordinates. And so you can make lines, points, and polygons within a GeoJSON. And GeoJSON itself is a pretty popular format for web mapping. And so a lot of like map displays, often the data is in a GeoJSON format.
Jeff,
Yep.
what's the difference here between, I guess, like the bounding box and this?
Okay, yep, the bounding box is usually just a square. It's a square that's like all the geographic information is within here.
Mhm.
The polygon or geometry can be anything. It could be a really complex shape or a really complex line. And so GeoJSONs allow you to just do much more complexity when it comes to the shape. And so typically in STAC catalogs, the GeoJSON also just usually has a bounding box also. I'll show you some examples of what I mean. But a lot of times there's a collection with the big bounding box, and then every item within it has a little bounding box. Okay, so that's what a catalog, collection, and an item is. They are JSON or GeoJSON files. They're really pretty simple. They're easy to read. The human can read them. They're machine readable. All right. But within these items is where we actually have or actually link to our assets. And so the catalogs can be anywhere. They can be sitting on a web server. They can be sitting in GitHub. Doesn't matter. The assets, though, don't have to be in the same actual place as the catalog. The assets can be anywhere in cloud storage. And so those two things, the assets and the catalogs, can be together. They don't have to be together. They're not like a package deal. What's important is that everything is linked together. and that through the structure and the hierarchy and the nesting, that you just know how it all connects. Oh yeah, so this was a picture of, let's just go there, geojson.io. So I think I showed this in a previous session, but this is a handy dandy website where you can make GeoJSON files just by clicking on the screen here. If I want to make a square, I can just do that. And over here on the right, I've now made a GeoJSON. And so I can export that. And there's a lot of programmatically, there's a lot of programs that can read the GeoJSON and help you with bounding boxes or areas of interest, things like that. When we did our first session we did in this series, we looked at an API from Planet, and we used the GeoJSON to determine like where our area of interest was for finding satellite imagery. Okay. Let's go to this one first. So I told you we're gonna crawl through some, like actually look at some. So let's go to the Radiant Earth STAC browser. So this is basically the starting point if you want to find STAC catalogs. What this browser does is it reads JSON and GeoJSON files that are in that STAC protocol, that STAC standard, and it renders it into this nice graphical user interface where you can click around and explore. So you can give it a URL, or you can just scroll here and see what catalogs might be of interest to you. Let's go to Microsoft Planetary Computer. We're actually going to do an example of that today. So let's click on that one. Okay, so now we are in the Microsoft Planetary Computer STAC catalog. And so now you can just kind of click through here and find things that might be of interest. All kinds of things. You can just scroll through, or you can do, I think, keyword searches. Let's see. Landsat. Does that work? No, it doesn't work.
And Landsat.
Landsat. Oh, I spelled it wrong. Okay, so if I did keyword search, cool, here we go. Looks like they got a few different, we have Landsat collection level 1, Landsat collection level 2. So it looks like level 1, or like the more raw images, and level 2 has been processed. Looks like atmospheric correction. So let's go into here. So now what we're looking at visually is a collection. This is the collection visual. Back here, the thing that these are all, we're in the catalog world now. Let's go back to our Landsat. Okay. Here we are in our Landsat collection. And in the collection, it just gives you a bit more information. They give you a nice description about what this data is. These are all the items. And so here's what I mean by bounding boxes within bounding boxes. Okay, so the blue box there is the collection bounding box. Like all the items occur within this, the entire world bounding box. That's because we're looking at Landsat data and it covers the whole world. And then if you zoom in, this is showing individual items, and each looks like each Landsat scene is a item. Can I click on it? Yeah, so I can click on it, or I can click here on the list over here on the right. All right, so I can go into that. And now here I am looking at the item GeoJSON file. It's nice, so it gives you a nice little map display. It, gives you metadata about what this item is. It's 30-meter resolution, tells you, when it was captured. Platform is Landsat 9. So it looks like this is, wow, this is really from 2 days ago. Okay. I guess they're working in near real time here. Nice. All right, so that's just the metadata aspect. If you look here on the left, these are all the assets. So the assets are like the actual files, right? And man, they've got a lot. So there can be multiple assets per item. So the item is like one time and place. And then the asset could be the red band, the blue band, the green band, and then any other kind of like processing, or products you do. Let's see, we have a thermal radiance band. And so for each of these assets, you can click on it, you can download it to your local machine, or you can copy it, copy the URL and stream it. What's cool is you see these little labels here, COG. So COG, if you remember, is Cloud Optimized GeoTIFF. We did a whole session on that several weeks ago. So cloud optimized geotiffs allow you to stream the data directly from cloud storage into your application, so you don't have to download entire scenes. Yeah, so this is a nice little display where you can click through and find things of interest to you. Let's go back. What else? Here, let's go back to the Landsat. I was going to show you this search feature. Landsat. Go back to that same collection. Okay, besides just browsing through and finding things, you can do a search. And I can do temporal extents, time ranges. So let's go March 22. Let's get, yeah, March through April of 2022. So that's my time range. And then I can do spatial extents. So let's just do something really small down in southeastern Arizona. And live demo, so you never know what's going to happen here. That's spinning a little bit too much. Yep, I did everything correct. I think I did everything correct. Not really sure why it's taken so long. Usually this is lickety split. Oh, interesting.
You have to select the small square.
The small square.
Yeah, it's
I mean, this thing?
zoom.
Let's just try it again. This is under somewhere. Okay, right over Agua Prieta. So, okay, yeah, that should work and that should work. No items found for the given filters. Okay, interesting. They just don't currently have anything for that area right at that time
You
in that
raise
place. Let's refresh it. Okay, here we go. Since I made my area of interest much bigger, yes, there are lots of items that met our search criteria. All right, and I click into one of these items, and then I can, find individual information about them. And let's just go to the very top of this thing. We'll start over. Okay, so STAC browser. What is it? It's a graphical user interface to interact and browse through graphically through all of these STAC catalogs. If you look over here on the right, you'll notice that some of them say catalog and some of them say API. Okay, so we did a session way back at the beginning about APIs, which are application programming interfaces, which is a fancy way of saying it's a programmatic way to interact and get data as opposed to through your web browser. So let's talk a little bit about the differences. So that is the difference between so catalogs and APIs is static versus dynamic. So when something's called a catalog, it is a static catalog, which means it just has the catalogs, the collections, the items, and the assets. And that's it. And so you're able to click through it, with the browser, but that's all it can do. If you have an API, that means the generator of the data is actually serving the data up through an API that they are serving. Once you tap into that, then it becomes something called a dynamic STAC catalog, which allows you to do these complex queries. That query that I was doing just a minute ago that half worked, that was on an API. So that allows, as an API, it allows me to do spatial temporal queries. Show me everything within here. Show me everything within this time range. If it's a static catalog, you cannot do that. All you can do is click through and browse. And that can get, cumbersome to drill down into folders to find things of interest. So the API really gives you a much more power in terms of searching for data and getting data of interest to you. All right, so yeah, we were just browsing through the STAC catalog. So you guys have an idea of what that is. We didn't hit STAC index yet, so let me just click on that. STAC index is basically your home for understanding STAC. It has a list of the catalogs. It tells you all the different tools in the ecosystem. It has resources to help you learn. It's just kind of like, the hub, the place you want to go to learn all about STAC. So STAC index and STAC browser, great places to start. All right. Let's see, we did static versus dynamic catalogs, browsing. Okay. Before we get to programmatically crawling STAC, which we're going to be doing, creating your own stacks. So perhaps you guys are generating your own geospatial data. Maybe you fly and collect drone data like I do, or maybe you are using satellite imagery, but you're creating value-added products of some kind. You're doing some kind of analysis, and you would like to share that analysis, and you would like to create your very own STAC catalog. You can do that, of course. So you just have to make the STAC compliant catalog, collection, items, assets. Those are JSON and geojson files. To help you do that, of course, there's a Python library called PyStack that will that can actually crawl over folders. Let's say you have a folder and it has a bunch of satellite products that you've created. It can help you crawl over that folder, go through every single one of those assets, and then start generating JSON and geojson files that are STAC compliant. And so I spent many months working on mine. So PyStack is the library to build your own STAC catalogs. We have some tutorials on these links here to help you with that. There's some more official STAC learning examples. What else? Here is my PyStack code. So I spent several months trying to make it good. And so on my own GitHub repo here, you can find an entirely written Python code that'll crawl over folders and create a STAC catalog for you. Okay, so before we get into programming with Python, are there any questions about kind of the idea or the concept of STAC catalogs? Anything in the chat? Nope.
So crawl is like a technical term.
Scrolling.
Crawl means you tell your little computer bot to go into a directory and look at files and do something. So that's what crawl means. It can be, you can use it in terms of the web, like a web browser, or sorry, a search engine goes out to all the computers and the servers in the world, crawls through them, gets information, and brings it back to you. Yeah, so crawl is just, I don't know, we're sending our little robots to go fetch things for us. Yeah. Okay, so let me start, let's do some Python. So you can interact with it with the graphical user browser. That's great. But this is a data science workshop, so we're going to show you guys how to do things programmatically using Python. Why are we doing that? Because it can give you more power. It can help you customize your queries, can help you automate things, and help you scale if you're trying to do things on a much bigger level. So we wrote it in Colab. So let me just, you can click on this. If you're following along, you can just click on this button to open up a Jupyter Notebook in Google Colab. Okay. So let me just refresh us here. What are we looking at? So this is Google Colab or Google Collaborate. It is a virtual machine that I've tapped into. And in this virtual machine, I am running a Jupyter Notebook. A Jupyter Notebook is just an environment where I can run Python code, run and analyze and get outputs from Python code. Jupyter Notebooks are really great ways to share code with people and to demonstrate and to teach. And so to get started here, I need to connect to my virtual resources. So I'll hit connect here. Okay, so I hit connect and I've got 12.7 gigabytes of random access memory. I have disk space, so I can actually save things to my my virtual machine. But please remember, this is temporary. It will disappear in like less than a day or something. These cloud environments are to do analysis and then get out. You don't save this and come back to it generally.
Except your notebook is there.
Except the notebook. So the notebook that you're using, which is the code that you see here, that lives in my GitHub repository. So that stays there. But the actual like bringing it to life in terms of running it on a virtual machine, that is ephemeral. You launch it, you do analysis, and then you shut it down. Okay, so I called my Python notebook stack crawl. We're going to do just that. So we are going to programmatically look at a STAC catalog in very similar ways to what we just did graphically, but we can do it with Python. Okay, first thing I need to do is install the libraries that I need for this. So I'm going to start clicking through the code snippets. So I need to install a library called PyStack Client, and then also install something called Planetary Computer. So we are going to interact with data sets that have been provided to us by Microsoft Planetary Computer. In a couple of weeks, we're doing an entire session on Planetary Computer, but for now, just understand that they have a very large data catalog, geospatial data. They have it up in cloud storage, and we can just tap into it and use things as we wish. Okay, so I installed those libraries. I will now bring those libraries, import them into my session. Okay, so next up, I'm going to open a STAC catalog at this URL right here. And so this is an API. And so this is not very different from the work we did with the Planet API back on the first session in this workshop series. So it's really quite similar. So Microsoft Planetary Computer has created, or they are serving out data in an API, and we can just tap into it, look for data. If we like things, we can pull it into our environment and analyze it. So I will hit go here. And so we've now just opened that catalog, so to speak. And so I can I can actually follow along a little bit in the browser. So if I'm in the browser, get down to Microsoft Planetary Computer STAC API. And so we're now in the same place in two different locations. Here's the graphical way to do it, and then here's the programmatic way to do it, but we're tapping into the same thing. So it helps to kind of use both sometimes, because the graphic is really easy to navigate, find what you're looking for. And then if you want to automate things and script things and do things in a more fancy way, then you start going to your Python. But Python's usually not where I start. I usually start just like, let me click through and see things with my eyes, usually where I start. Okay, so let's do this. Let's look at all the collections that are within the root catalog. And then tell me, how many are there? There are 123. So if I go back to my catalog here, not index, this one, yep, 123. And so there are 123 of these individual collections. And so with the power of the API, I don't have to click through all 123 to find what I'm looking for. I can simply do spatial and temporal queries to find things that I want. So it is amazingly much more powerful.
Here's a question.
Yeah, Ravindra?
So Jeff, I'm in the collab. I'm trying to follow the code that you're showing, but how do you get to the browser thing?
Okay, the browser. Got it right here.
Oh,
Let's see, let me copy that link address. That's the browser.
okay. Thank you.
Yep, you're welcome. Okay.
Question by Matthew.
Okay, what was the question? Is it in the chat? How do you know the URL to use? Aha, yes, exactly. That's where it helps to have the actual browser. You're not going to really know what to, where to tap into or what the endpoints is. You find them through the STAC browser. And so that's always the starting point. Is you start here, and then you're like, oh, look, Microsoft Planetary Computer has things of interest. So I can click on that. And then within here, I can find those specific URLs. If I go to source, it's right here. So that's the API endpoint, or the STAC API endpoint. And so that's what we're tapping into, is this right here. Thank you for that question. Okay, let's go back to my Python. So yeah, I was saying we have 123 different different collections we can look at. It's pretty cumbersome to click through all that to find things of interest, and that's why we're doing things with Python, so we can do intelligent and complex queries, spatial and temporal. All right, thank you, Ravindra. Okay, so we looked at here is how many catalogs are there, or sorry, how many collections? There are 123. Now we're going to print the name, the ID, and the title for all 123. So you can do it this way. And that's just like a giant list of all the different collections. Maybe that wasn't necessary, but I just wanted to do it. Okay, so here's where we're going to create a custom spatial and temporal filter to find assets of interest. So it's really simple. You make a variable and call it time range, and then you put some kind of range, just like that, in that format. And so for that one, I said find the time range is December 2020. That's what that time range says. And then I make a bounding box. That's also fairly simple. The first two coordinates that you see here is the southwest corner in longitude and latitude. And then the second set of coordinates is the northeast corner in longitude and latitude. Took me a minute to figure out like the order or like which way I did it, but figured it out and wrote it here. So we remember. Okay, so I'll just create my little filter. Okay, created. Now I'm going to, instead of looking through 123 collections, that might take a long time. I'm going to narrow it down to a specific collection. I found there's a collection I like. It's called Landsat C2-L2. So that's the thing that we looked at the beginning, the Landsat collection. I'm going to just look in that one specifically. And so, yeah, let's do that. Let's do our spatial and temporal filter, but limit it to just one specific collection, that one there. Okay, it responded with there are 8 items. Okay, 8 items, great. So now I want to show me those items in a table and show me some characteristics about them. We are using a package called GeoPandas to do that. I'm sure there are other libraries that'll do similar things. And so within our specified collection, we have 8 items, and here they are. That's an item, that's an item. There are 8 of them, and it lists kind of all the metadata that was attached to those specific items. And so once we have these metadata tags here, we can do even more filters. Here, let's just see what all kind of other metadata do we have. I guess got the path, the satellite took, the sun azimuth, what type of correction, the sun elevation, cloud cover. Hey, cloud cover. That could be useful. So let's do that. So within our 8 items, let's do a filter to find the item that has the lowest cloud cover. And so that's what this little thing is, this one line is doing. It's looking at the metadata tag cloud cover here, and I'm saying, find me the minimum of that. So it does that, and then it just tells me which one it is. I mean, I could have done that probably manually with my eyeballs, but we're gonna do it programmatically. Okay, so that's my my one item that has the lowest cloud cover in my area of interest that I'm interested in. Okay, and so we've drilled down to item. Now let's see, what are all the assets associated with that one item? And here they are. And so for that one, spatial temporal item, it's got several assets. And here's all their names here on the left. Some of them I don't really recognize what they are. I'd have to oh, wait, it's written right here. Cool. Blue band, radiance, emissivity, green band, near infrared band. So these are all individual assets. And then over here, it says what type. And so it tells me that they are TIFFs, they are geotiffs, and they're actually cloud optimized geotiffs. So most of these assets are all cloud optimized geotiffs, which is fantastic. That means if I wanted to, I could just now bring parts of that geotiff into my my computing environment without having to download the whole thing. And you can look at a previous lesson I did on cloud optimized geotiffs on how to do that programmatically. But let's just keep rolling here. Let's do some preview. And so interestingly, there's one asset called rendered preview, and it's a PNG. A PNG is an image file, but it's usually like low quality, like low resolution for web viewing. So let's just let's look at that. Okay, before I do that, I have to turn it into a dictionary. That's just Python speak. And then I can actually view it. Okay, what do we have here? Looks like we have a Landsat scene over the Olympic Peninsula up in Washington State. So that's not the actual data. That's just like a low-res preview or a thumbnail, I believe is another way to say it. Okay, what else can I do? So I use the preview just to see what is that image? Okay, it's the Landsat over Olympics. Now I can use that same API endpoint to then actually get the data band, the actual data that I want. And so let's say that for argument that we want the blue band for whatever reason, I can just do that. What that does, what it spit out is a URL of where that blue band is located. So in the STAC catalog world, the assets are probably sitting in cloud storage somewhere. And in this case, it's in blob, which means it's sitting in cloud storage from Microsoft Azure. So Microsoft is Azure is their cloud computing, cloud storage system. And the word blob is associated with them. So anytime you see blob, it'd be like Microsoft. So that is the URL for where that data is actually housed. So, in a Microsoft server somewhere, it might even tell me where. European Union West. Okay, so physically, I think it's in the western part of Europe. Okay, let's see. So that's where we get that asset. Now let's get some information about it. Without downloading it, I can find out if that asset is available. I can get something called an HTTP response code. Like, is it there? Can I get it? I can get what type of file it is and then the file size. All right. I'll just run this code block. And down here, we have a status code of 200. Meaning, yes, it is available over HTTP. I can grab it. Thank you. It's a TIFF and it's 75.27 megabytes in size. Okay, so I learned what that asset is a little bit, how big it is. And then let me just pull it from Microsoft's cloud storage directly into our notebook here and look at it. That's all we'll do. So I'm going to use a library called Rio Xarray. A few weeks ago, we talked about ZAR and we used a Python package called Xarray. So Rio Xarray is very similar. It's for arrays, multi-dimensional array data. But Rio, I think, it gives it more of a like a geo feel to it, more like geospatial. I don't know. Do you have an idea?
It's gonna read files.
Rio Xarray.
Yeah, read input out.
All right, so to do that, we have to install the Rio Xarray library. We'll do that first, then we will bring Rio Xarray into our environment, and then we'll run these little bits of code to then just display this asset. So let's just go ahead and do it. Okay. What you're looking at here is just a rendering of the blue band of of that Landsat scene. Kind of interestingly, I typed in this overview level 2. So if you remember from cloud optimized geotiffs or COGs, that what makes them unique is that they have overviews and tiles baked directly into the file format. And so in this case, I wanted to just look at an overview because it's coarser and it's much easier to bring it in. Doesn't take very long to just like pull it into my environment and look at it. So I am not bringing in like the full resolution of the data. I could, no problem. It's there for you to get it if you want, but just for visual sake, I'm like, give me overview level 2, which is a coarsening of like the full resolution. Okay, so yeah, here's the result. It's just displaying it. And that's as far as we're gonna take it. So you could just keep going, this is Python, so we can do anything we want. I can now just bring over, instead of bringing the whole scene, I could just do like a little area of interest if I wanted to, and then any kind of analysis available to you in the Python world. Okay, so to kind of sum up here, we ran a Jupyter Notebook in Google Colab, and we interacted with STAC catalogs and we found something of interest. We pulled it into, we queried it a little bit, trying to figure out what it is, and then brought it into our own Python environment. Did that all using Python. And then going back to just the larger lesson today, spatial temporal asset catalogs. Yeah, they're just a way to, I don't know, kind of an open source community way to try to document, catalog, describe, and share geospatial data. And hopefully there's more momentum. It seems like there's a lot of groups and people in the geospatial world that are using this STAC metadata protocol. And so I think it's very nice thing to be aware of, and great programmatically to find and use data for your own purposes. So I'll take any questions about STAC or anything else.